Hi guys, today we're going to look at some problems with mass stoichiometry regarding limiting reagents, where you have one thing that's actually in excess and you need to work that out before you do your mass calculation as previously. So let's have a look at the example from the textbook really quickly. A skateboard is made from a deck and 4 wheels. So we can say that this is like a reaction where one deck plus 4 wheels gives us a skateboard. So if we have a look at this situation, if we have a look at the situation that's down here, we can actually work out how many skateboards we can make in total. So let's count the wheels: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But there's only 2 skateboards. So the problem here is that you only need 8 wheels, but you're going to use the 2 decks. So you can't use the wheels for stoichiometry. You can only use the decks. So let's just write that down. So we've got 10 wheels plus 2 decks. But this only goes to make 2 skateboards plus 2 wheels in excess. Okay, we call this the excess reagent. Okay, so the skateboard's obviously made of a deck plus 4 wheels. All right, we therefore call our limiting reagent the decks. Or limiting reactant, same thing. These are our limiting reagents. When we do the stoichiometry for the problem, we know that the amount of skateboards we end up with is not now based on the wheels, but it's based on the amount of decks we had, these being the limiting reagents. So what we're going to do now is we're going to look at a real life problem with this. Let's solve this. So a solution containing 20 grams of dissolved sodium hydroxide is added to a solution containing 25 grams of aluminium nitrate to form solid aluminium hydroxide and aqueous sodium nitrate. The equation for this reaction is this. I'm going to write it here as well so we can do some calculations on the board with them. So I'm not going to put the states in just for a little bit of time saving, but 3 sodium hydroxides. Now this is already balanced for you. That doesn't always happen. You're going to get many problems where they just give you the word equations and you're actually going to have to come up with these formulas and balance these yourselves. All right, so AlOH3 plus 3, just make sure you can see this, sodium nitrates. It's a bit of a screen full, this one. All right, let's have a look at the stoichiometry to start with. I know that we need 3 of these. This is 1, there's no number in front of it. This is 1 as well, there's no number in front of it, and this is a 3 there. So I know basically that for every 3 sodium hydroxides that I use, I only need 1 aluminium nitrate. The converse of this is that for every aluminium nitrate I use, I need 3 sodium hydroxides. If we don't have a 3-to-1 ratio exactly, then one of these is going to be in excess and one of these is actually going to be limiting. So what we need to do first is to work out which one is in excess and which one is limiting. The only way that we can do that with masses is actually to convert them to moles, because you can't count the number of molecules in with a mass. You need to count in moles. So let's do that to start. Let's do the sodium hydroxide first. The number of moles of sodium hydroxide is equal to mass on molar mass. The mass of sodium hydroxide is 20 grams. Okay, and the molar mass of sodium hydroxide is 22.99 plus 16 plus 1.008 grams per mole. Okay, let's do that on the calculator really quickly. Okay, and you end up with about half a mole, 0.500250013 grams, and grams cancel, and you end up with moles. We're going to do the same thing now for the aluminium nitrate. So the number of moles of aluminium nitrate is equal to mass on molar mass. Okay, there's 25 grams of the aluminium nitrate, and I don't know this one off the top of my head. The molar mass of aluminium nitrate is, let's go down and have a look at our periodic table. Aluminium is 26.98. Plus we need 3 nitrates, so 3, 14.01 for the nitrogen, plus 3, 16, so there's 3 oxygens, and this is grams per mole. Okay, let's put that in the calculator. So 25 grams divided by 26.98 plus 3 nitrates, so 14.01 for the nitrogen plus 3 16s per nitrate, and we end up with 0.1173653.819 moles. Okay, now what we need to do is we need to work out the ratio. Do we have a 3-to-1 ratio, or do we have something else? Okay, so what we need to do for that is we need to divide them. So the number of moles of sodium hydroxide to the number of moles of aluminium nitrate. Now we're expecting this to be 3. If it's not 3, we need to know what it is. Okay, so this is 0.500250013 moles divided by 0.1173653.819 moles. Okay, I'm going to do that quickly on the calculator. And the answer we get is 4.2604130021. Notice that there's no units here. It's just a proportion. Now, we expected this to be 3, but it's actually bigger than 3, which tells me that this is larger than we expected, or this is smaller than we expected. What this means is that the top is in excess. We have too much of it, or the bottom is limiting. It doesn't really matter. But what we need to know, the important thing that we need to establish here is which is in excess, which is limiting. Now, much like our skateboard problem before, we didn't know how many skateboards were going to be formed based on the number of wheels. We actually had to use the deck. We had to use the limiting reagent to work out how many skateboards were going to be formed. So we need to use the calculations based on aluminium nitrate for the rest of this problem. So let's actually have a look at the rest of this problem. First, they want to know which is the limiting reagent or the limiting reactant. We just worked that out. So I would write a sentence like, therefore, the limiting reagent is aluminium nitrate. Okay, I would write that in a sentence, all right? What they want to know next is what's the mass of aluminium hydroxide that will be formed. Okay, we can go and work that out now. The mass of aluminium hydroxide that's going to be formed is purely going to be based on this number here. So if we go back up to our equation, we can see this. We can see that every aluminium nitrate gives us 1 aluminium hydroxide. So these are in a 1-to-1 ratio. So I actually know that this number of moles here, right, is actually equal to the number of moles of aluminium hydroxide as well. And just for a little bit of space reasoning, I'm just going to get rid of this stuff so I've got some space to do some further calculations. So I'll just remind everyone that this was excess, this is limiting. Okay, so this is also equal. This is a 1-to-1 ratio. This is the number of moles of aluminium nitrate. It's also the number of moles of aluminium hydroxide. Okay, so this is a fairly easy problem now. All we need to know now is the mass of aluminium hydroxide formed, which we can convert from the number of moles. So I'm just going to come back up here. Let's just start here again. My number of moles of aluminium hydroxide, now in a question, you don't really need to write this out again, I'm just doing this for clarity, is 0.1173653.819 moles. Okay, for a mass, it's equal to the number of moles times the molar mass. The number of moles is 0.1173653.819 moles multiplied by, now the molar mass of aluminium hydroxide is different to that of aluminium nitrate. So we get the 26.98 of aluminium. Okay, now we've got 3 hydroxide, so 16 plus 1.008. So just for you, those of you that don't know what I'm doing here, that's oxygen and this is hydrogen, and there's 3 of them. Okay, and this is in grams per mole. Okay, inverse moles and moles cancel. When you multiply them, you end up with an answer in grams. Just check that because we are looking for a mass. I'm going to pop this into my calculator. You might want to put these in brackets as well. It's just always safe. 0.1173653819 moles multiplied by, in brackets, aluminium 26.98 plus 3 hydroxides per aluminium, 16 for the oxygen plus 1.008 for the hydrogen. And we end up with an answer of 9.15496,925, and we end up with grams. Okay, so that's the mass of aluminium hydroxide formed. Now let's have a look at the numbers that we were given at the start of the question. We were given that to three significant figures. Everything on our periodic table is to 4 significant figures. So our most limiting reading here is 3 significant figures. So we need to round down here. So it's 9.15 grams to 3 significant figures. And that's how you do a limiting reagent problem.